So at this point, we would like to I would like to turn over to our chapter president of the IIEE CDO chapter to give his welcome remarks. Please, by virtual applause, let us welcome Engineer Ferdinand A. Bernasor, REE.
Thank you very much, Engineer Dondanon A. Baharla Jr., our MC, at the same time the Social Manager of IIEE Cagayan de Oro Chapter. Good afternoon, everyone, fellow electrical practitioner. I will please give me the opportunity to introduce the Board of Directors of IIEE Cagayan de Oro Chapter and the officers, headed by yours truly, Engineer Ferdinand A. Bernasor, the President, the Vice President for Internal Affairs, Engineer Claro Samuel P. Fontanilla, Vice President, External Affairs, Engineer Ray Darius B. Belga, the Vice President for Technical Affairs, who is responsible for this webinar, the technical webinar, Engineer Christopher Isa Dolino, our Secretary, Engineer Roberto Piga Jr., our Treasurer, Engineer Susan Esquinal, our Auditor, Engineer Jubin N. Magto, PRO, Engineer Alan L. Sadora, our Social Manager, Engineer Michelle Q. Magsayo, Associate Member, Mr. Bibilor Isbito, and our immediate former President, Engineer Leopoldo C. Capascia, and all the representatives and advisor, and my advisor of IIEE CDO chapter. Thank you very much for supporting our team, especially to our second-timer most outstanding Governor of Northern Mindanao, Engineer Sandro V. Villarosa. Thank you for this team. We know that we work hard despite of this pandemic, and we are now in the third IIEE Cagayan de Oro chapter technical webinar and the first virtual general membership meeting after this technical webinar. This is the first time that we have a virtual general membership meeting of all the members of IIEE Cagayan de Oro chapter. And we would like also to thank in our auditor, Engineer Susan Esquinal, for donating IIEE t-shirt for raffle for free. Thank you very much, ma'am, for your generosity. And I would like also to thank my advisor in IIEE Cagayan de Oro chapter, the former president, Engineer Rojien V. Morcilla, professional electrical engineer, was also our speaker in global and holistic perspective for energy management. Thank you very much, engineer. Then also we would like also to thank the presence of IIEE national officers headed by IIEE National President of Internal Affairs, Vice President Lyndon R. Banqui. Thank you very much for your time, sir. And also our Professional Regulatory Board of Electrical Engineering, very supportive of IIEE Cagayan de Oro chapter, Honorable Francis B. Mapili. Thank you very much, Honorable Sir, for your time in joining the webinar, technical webinar, and also the first virtual general membership meeting. On behalf of the IIEE Cagayan de Oro Chapter Board of Director Officers, Representative, and my advisors, we would like to thank each and every one of you from the different chapter all over the globe who attended this third IIEE Cagayan de Oro Chapter technical webinar. And we hope that you will get something in this technical seminar, even that we are having virtually just because of this pandemic. And fellow electrical practitioner, observe the IETA protocol as Cagayan de Oro now having an MECQ. Keep safe. Please observe physical distancing. Wear face mask, face shield. Always have your alcohol. Thank you very much, and God bless us all.
Thank you very much, President Ferdinand A. Bernasor, for that welcome remarks. So the first part of our event is a technical webinar. Our speaker is currently the chairman of the Electrical Engineering Department and professor of the University of Science and Technology of Southern Philippines. He is a professional electrical engineer, and he graduated with a degree in Bachelor of Science in Electrical Engineering at Mindanao Polytechnic State College at Cagayan de Oro City. He has in Masters of Engineering with specialization in power systems and power economics at the same university. He was a project leader and project inspector of Mindanao University of Science and Technology in 2013 to 2014. He also serves as a technical consultant at Synergy USAID and at various electric cooperatives in Mindanao and St. He was also a production operator at Universal Robina Corporation in 2008. So help me welcome our resource speaker by virtue of a virtual applause, Engineer Rojien V. Morcilla, PEE MOE.
Good afternoon, everyone. Madunggan ba ko? Can I be here, sir?
Yes, sure. Yes, sure.
Okay, thank you.
Yes, sir, you can be heard, sir.
Okay, say thank you, Engineer Paharla. No, thank you also for the participants who are here today to listen to this. Hopefully, I will be able to share to you something that you might be able to use as you have your day-to-day activity as well as your career and also in our practice in electrical engineering. Okay, so I'll be sharing my screen. Okay, so for today's webinar, technical webinar, we will be talking about this what we call a global and a holistic perspective regarding energy management. So we will be talking about first that why do we have this energy management? What is the reason why do we need to manage energy? And what is the process later on? We'll be talking about that. What is the process on doing the energy management as well as the details basically on the energy audit as we go to the deeper sense of energy management. Okay, so we'll first go to the reasons. Okay, so as we know that the global trend now, as we have the global trend of today, that the energy consumption worldwide grow by 2.3% in 2018, and it is nearly twice the average rate growth since 2010, and is foreseen to grow by 57% over the next 25 years. So imagine that very large growth in energy as we have in our country today, in globally, no, so globally energy consumption. And it's seen that by year 2030, 56% of the world's energy use will be from Asia. So, from the world perspective, Asia would be 56%. Energy usage, consumption uh, will be that vast from Asia in the next 2030. And this electricity demand will grow by about at least 40% by 2032. Those are their projections. Okay, so with this, new power generation has to be built, and it's equally around 300 power plants, around 1,000 gigawatt to be needed to meet the electricity by 2030. And currently, with this growth of energy demand as well as power generation, 64% of the electrical generation relies on coal and fossil fuels, while 85% are greenhouse gas emissions results from energy consuming activities supported by fossil fuels. So basically, the world is dependent on this uh, coal and fossil fuel based energy. Okay, so if we have here the global trend, if we see the pie charts of the globally, as you can see here, the oil base or the fossil fuel base as and the coal forms a large part in the energy demand in terms of metric tons of energy. And in terms of electricity generation, no, as you can see here, 38% is coming from coal and oil is around 3%. So, ang atong global trend. And if we can see also the whole demand, no, for the whole world, no, United States is consuming around 16% of the energy, and China is around 23%, and the rest of the world is around 40%. That's why, in terms of carbon dioxide emission, no, in terms of CO2 emission, China forms part around 30%, United States is around 15%, and the rest of the world is 35%. So imagine that vast of carbon dioxide emission. So this is the trend of the global trend of the energy. Uh, as you can see here, coal tops around 30 plus percent. However, it's going down globally, and gas is going up. No, and with hydro is also constant lang siya. Nuclear is going down, and some renewable energies are going up, including the wind, the solar energy. Those are very promising renewable energy that is going up. But still, the world says that we are dependent on this fossil fuel-based technologies as we cater this growing energy demand with respect to the electricity, as well as other factors that needs energy, especially the electricity that we are using fossil fuel based. In the Philippines, this is our trend based on the 2017 report. No, uh, this is the trend. No, as you can see here, that the transport sector forms part of the large energy consumption, but the other part is from the residential level, no, in terms of metric tons of energy. But as you can see here in the chart, no, based on this, even if the electricity sector is just the third one in terms of the metric tons of energy consumption, but in terms of power generation, no, due to the vast amount of energy that we get from fossil based technology, we cater around 46% of the emitted carbon dioxide in the atmosphere. Okay, so now this is also the trend in the Philippines. No, for the past 1985 until 2020. So compared to the global trend, the Philippine trend is not that far enough. However, The one difference that we have with respect to the global trend is that our coal uh, our coal technology is increasing compared to the global trend, which is now decreasing. No, but still, we can see here that the Philippines' dependency on coal is around 50% in 2020, and same as the world trend that our solar and wind energy are now coping up with this energy. However, we still is dependent on fossil-based and fossil-based technology. So this is the demand trend on with respect to the Philippines. The Luzon is the highest has the highest demand, followed by Visayas, and next is Mindanao. And one thing that we can notice here is that with respect to demand, no, residential and industrial are at par with respect to its consumption, the energy demand consumption. So basically, no, uh, residential consumer and industrial consumer are in terms of electricity consumption are the one um, when we say increase in the energy consumption of electricity, this will form part from these two sectors, the residential and the industrial level, industrial na consumers. Okay, so if we can also zoom in to Mindanao, the coal has the large part, 61%, and followed by the hydro is 36%. So, but now the coal is 61 and 5% is oil. So that's forms part that around uh, 66% of the energy coming from fossil fuel based technology. That is to cope up with this increasing uh, electricity demand in the country and particularly in the island of Mindanao. So as we also have the data here from Mindanao of 2020, our mix today is we have already 71% coal and oil base is 2.7%. So imagine that vast energy coming from fossil fuel to just cope up this uh, energy need or electricity need in Mindanao. Okay, so though that is the trend, that is the what is happening in the generation side. No? Just to cope up this electricity demand increase in the country. Now, with respect to this being dependent to fossil fuels, technology, etc., uh, we have the result what we call the global warming. As a result, global warming happened, no, due to this carbon dioxide emissions in the atmosphere because it's worldwide. Not only the Philippines but worldwide, we are dependent on fossil fuels. That's the effect. There's a lot of drought, typhoons, flood happening, uh, even dengue fever. You link it to global climate change and global warming. No, so this is the effect now. It it's a global trend, and the effect is also global because of this technology. That's why globally, uh, the other countries are going to this different technology already and trying to mitigate this use of fossil fuel based technologies um, such that it will lessen the effect in the global warming. Now, also they also link that the COVID-19 situation in the country is linked to this what we call global crisis, the climate change. There are also papers saying that it's linked to this climate change. That's why we have this COVID-19. Although the COVID-19 pandemic disruptions to the disruptions to the energy sectors. During the crisis, what happened was the global energy dropped by 5% in 2020. No, so the energy demand dropped because of uh, because of this global pandemic by 5%. And with this drop, syempre, no, the global energy related CO2 emission dropped by 7% in 2020. Since the energy demand, as we know that the trend, the global trend is we are dependent on fossil-based technology. So, ni-drop din yung uh, CO2 emissions natin. So, it's a healing thing that's happening to the Earth, to the climate change. And but the problem here is the global energy investment dropped by 18% in 2020. So, yung negative part, no? Now, in the case of the Philippines peak demand dropped by 1.9% in 2020. That is because of the pandemic, no? And and the Philippine electricity consumption dropped by 4% in 2020. So, kung baga, due to the pandemic, it really disrupts the energy sector, no? Nag-drop tayo we dropped the energy demand. However, uh, due to that drop of energy demand, we drop also the carbon emission. But even if we have this that the drop, no, that is artificial. It is because of this pandemic lang man, no. Right now we are still going to that fight, no. We are still going to that fight that we are more than 50% dependent on fossil-based technology. Okay, so the question now is that is there another way to mitigate such increase in energy demand trend? No. So the trend of the day is that the energy demand is also I always increasing. No? That's always happening because there's a lot of technology that use electricity, that use energy. No, so but how do we mitigate those things to happen? And is there another way to mitigate such increase in CO2 emission trend? No, without going to this CO2 emission. Okay, so that's why we have what we call the energy management. Now, what is this energy management? The energy management is a process of tracking, monitoring energy to conserve energy in a building or facility. In such a way, if we can manage our energy, no, because if we are not going to manage our energy, there will be possibility that our demand would be really increasing in the future. But if we can manage and monitor our energy, there's a way that we can mitigate this very steep increase in the demand of electricity or energy. No? So this energy management is another way that we can use to mitigate such happening. Also, with the use of energy management, no, if we can reduce, no, if we can conserve energy, we can reduce energy, we can reduce the carbon dioxide emission. So, because as we know, no, we are dependent on fossil fuels technology. If we can reduce our consumption, therefore, we can reduce the production of this carbon dioxide in the atmosphere. No, imagine a lot of facilities will be going to energy management, and that's large amount, no, of conservation would reflect into a big reduction in terms of demand as well as in reduction of carbon dioxide. Another thing is that by having such energy management, we can introduce renewable technology in our facility that could again mitigate the production of carbon dioxide uh, in the atmosphere using our own energy, using renewable energy technology. So that's a three effect, no? By that effect based on the energy management technology. Okay, so in doing energy management, it's actually three parts. The first one is the energy management. The other one is the energy efficiency and the energy management system. You cannot do energy management without energy management systems, ENMS. Okay? Now, the energy management here is a systematic and continuous effort to improve energy efficiency. So it's a management perspective in doing energy efficiency within the organization. So it's really a decision of the organization, a decision of the company, a decision of the facility, or the management to go into or go into energy efficiency measures. So it can take in any forms or involve all types of interactions with energy from procurement and purchasing strategies to technological improvements and behavioral change. No, so imagine that from procurement and purchasing strategies in the facility, whether you are in production, we are into different business types, and technology strategies in technology improvements. So what particular technology that you're going to purchase or to do such that you can be more efficient, what technology you're going to provide such that you will be more efficient in terms of energy. And lastly, the most important one is behavioral change. How do you change the behavior of the people inside your organization such that everyone is going to that energy efficiency level? So later on, we'll be talking about this different categories of energy management. And what's big part there, you can see there that one important thing is the behavioral change. No? It's the least cost of all the categories. No? And you can implement it right away. Just policy change in the organization. Another one, if you have the management, the energy efficiency. Energy efficiency is use of the minimum amount of energy while maintaining the desired level of economic activity of service. So you cannot mm, go away with your services and activities. So what would be uh, what would be the strategy that you need to do in order to get that level of economic activity such that you also lessen your energy consumption? So in other words, energy efficiency is the amount of the useful output achieved per unit of energy input. So it's actually optimizing, no? Optimizing, optimizing energy such that you can produce still that particular output. And another one, no? If we have this energy efficiency, then we go to the energy management systems. So in creating the energy management, it can be tailored to the size and needs of any organization. So depending on your facility, depending on your organization, or depending on your sectors, uh, you can craft your own energy management system. So in order to be effective, it requires implementation of a plan of our system, which is flexible, value driven, and in alignment with the strategic aims of the organization. So basically, it when you do the energy management system, it's tailor fit to the need of a particular organization. No, Diba? It does not mean one size fits all. So depende if you are in the university like us in the USTP, this is how we do the energy management systems. If you are in the industry, if you're in the production area, you have also another thing because you have different source of energy, different usage of energy. You have different characteristics of energy usage, and you also have different uh, uh, facilities that use energy. Okay, so energy management, no, systems are developed, are designed to help organization by providing systematic and well-structured framework. So parang curriculum framework that would fit the organization. Parang mga those are policies and guidelines and that aim. The NMS supports energy management, but is not suitable for it for dependency. No, dependency for a particular organization. Okay, so what energy management can do to you if you are in that facility, if you are that doing energy management? The first one is it reduce energy costs and minimize risk. No, so many have been proven that by using energy management, they have reduced their energy cost from a large cost, very large cost, it reduced to a something percentage of their energy and minimize risk. No, financial benefit and reduced exposure to price-related risk. Why price-related risk? Especially now we are going to the if we are indulged into electricity market later on. If we are I think Luzon and Visayas are they are already in the WISM, and if Mindanao will be in WISM, we can if you can participate in the WISM, you can minimize your risk of exposure using energy management. Okay, so you can manage your energy such that you minimize the risk of exposing to a higher price in the market later on. So it's strategically doing thing such that you can minimize the risk of having that high price later on in the market. No, because there would be a possibility that there would be a time that there would be a high price in the market later on. No? And also uh, have that benefit of uh, consuming energy at lower price later on if you're going to that market strategy. So you're doing the reducing the exposure to the market, to the price risk related. Another one is we comply with the policies and regulations frameworks. So one of the regulatory framework and energy policy is we have the Act, the Republic Act 11285 is the act of institutionalizing energy efficiency and conservation, enhancing the efficient use of energy and granting incentives to energy efficiency and conservation projects. So every facility now, no, based on this Republic Act, especially government, has to go, has to institutionalize energy efficiency and conservation. So it's if we are going to follow do energy management, we follow this Republic Act. Okay? Another one, we have the complying with ISO 5001, no, energy management systems, and ISO 5002, the energy audit. Okay, so we're going to go through those ISO standards, follow that one, then you can do the energy management. Another one is you improve the organization's effectiveness. No, uh, the productivity level, the health and safety and equipment performance would be much better. No, especially on safety and health. No, safety and health of your employees, as well as the productivity, especially because again in energy management we are optimizing, no, optimizing lesser energy to optimize that particular service or output. And equipment performance, what would be what would be the most efficient equipment that we're going to utilize in our particular industry that such it would reduce our energy consumption. Okay, and lastly we have to improve the corporate social responsibility. That's why if you're in the industry, uh, so if you're a company doing energy management, you improve your corporate social responsibility. You demonstrate good practice to both customers and shareholders. No? So imagine if you are a company following this energy management, reducing their energy consumption, so and you follow this regulatory, so you demonstrate good practice to both consumer and shareholders. Wider reputation of organization raise its profile and help the organization gain competitive advantage in the market. Okay, so this the significance of energy consumption. No, it provides innovation of product systems because you are innovating your products such that it would produce, it would be more efficient. No, you reduce your energy cost. And lastly, the most important one, the environmental contribution. So you contribute even simple and small. Parang this even you contribute small, but if there would be many, no, many doing energy management, the environmental contribution would be bigger. No? So three part innovation of product systems, reducing the energy cost and environmental contribution, such that you create market competitiveness because you have a clean company image, quality, the price, no, because you optimize everything, your price will be lesser also, and customer service. So such a way, this would become a good standing enterprise in the 21st century. So what can energy management do? So these are the companies that have done energy management before. So Ford saved around $75 million through effective energy management. USAA realized around a 5% annual average savings and increased the asset value. California building by in their California buildings by 1.5 billion due to energy efficiency upgrades. Kodak, no, wala naman si Kodak karon. However, Kodak before have done energy management. They save around 8.6 million in the operating cost in 2002 for its energy management efforts. Heinz, no, estimates the difference in operating cost between its energy efficient building and inefficient building. It's more than $13 million. So another one is Fairfax Country Public School, a university, a school, no? So estimate around annual energy saving of 4.5 million for energy efficiency improvement. So those are the companies, different companies from schools to different industries that's doing energy management that they have saved something, no, for their company, okay, due to the energy management. So the question now is how to do the how nothing, no, the how. How do we do? How do we manage energy? How do we manage energy? So it's like what you see. Energy management is like a cycle. It's just like plan, do, check, act. No, so you can see it in the diagram. No, it's energy management cycle. No, so you start from understanding the energy use, the planning and organization, implementation, verification and monitoring, then company commitment. So it's like a cycle. The plan, do, check. So later on, we'll be going into details of this. How do we do the energy management? Okay, so steps and energy management. Paano ba yung steps ng paano ba maggawa ng energy management? So you start actually understanding your present usage, no? Ano ba yung present usage mo? How do you use energy? The question is understanding the cost. Is the cost of energy in the perspective of your company, in the perspective of the facility, is that big? No? So that's that big na ba? Masyadong malaki na ba for the company? No? Then you compare. How do you know that it's big? You compare yourself. No? You compare yourself. So later on, we'll see paano ba mag-compare. No? You compare yourself, understand when you use the energy, understand where you use energy. Such a way, with just understanding the present usage, you then identify, you find the saving opportunities. What areas are going to save energy? So you then match the requirement, they maximize the efficiency and optimize the supply. So later on, we will going through each one of this. Okay, but before that, based on ISO 5001, the energy management system, there are six key components of ENMS. As what I've said kanina, you cannot do energy management if you have the energy management system. It's like a system. No? So para siyang cycle that you do in your company, and this is the ISO 5001 standard. So six concepts. The first one is commitment. No, commitment from your organization, from the management. You set the rules and the responsibilities. No, so the management should be able to have that commitment from its staff, lahat ng mga employees, and identify what are the rules and responsibilities in your energy management in your company. So you set here the area here, no, the management participation. What are the rules, the responsibilities, uh, and such a way you create the policy. So dapat meron siyang policy na ma-create yung for this energy management. After that, you identify the significant energy users. So what are the significant energy users in your in your facility or in your company? The third one is the energy performance indicators. Identify what are those indicators. The fourth one is the opportunity list, no, the improvement. the operational control, and the review no part. So it's like this manner, no? You do the management review. You start with the management responsibility, then you create the policy, the planning. After that, you implement, you check, no? After that, check, then implement operation, then after what, you management review. It's like a cycle, a plan, do, check, uh, PDCA, no? Plan, do, check na activity. Okay? So, let's go to the steps. Step one is understanding your energy cost. Ano ba yung energy cost? Understand your demand. The demand, the rate, or how fast the electricity is used in your facility. No? What rate are you in? If you're in Cagayan if you're in a different facility, you will be subjected to different rate level. If you're a residential, if you're a depending on your demand factor. No, the demand rate and or how fast electricity is used in your facility. The energy, how much electricity you use in a month, in a year, in a day, if you can get it. Then the time of use, when the electricity is used, what part of the day. As in a university, like for example, in our clinical in the university in the case, we use in the morning. However, there are facilities that use in the evening. So depending on your usage, the time of use, and the power factor, no, your apparent rate of use versus your real rate of use. So what power factor are you? Okay, so you understand your energy cost. Then number two, compare yourself. After those data that you gathered, the demand, energy, time, the time of use, and the power factor, identify, you compare. No? First is external comparison. How does your level of energy consumption compare to other similar industries, facilities, and sites? So compare yourself. If you are in the production industry, you compare your electricity with them. How do you consume energy compared to them? Facilities and sites. No? What level of consumption is achieved, no, with the best operating practices and industry benchmarks? So you benchmark with the others. So what level of consumption? Ilang kilowatt hour ba energy is achieved in operating practices in the industry benchmark? And after that, external, internal. How does your consumption or energy performance this month compared with the last month or the best month in the past 2 years, for example? Okay, so you compare your monthly consumption, you compare your monthly demand, your monthly uh, cost of energy, your consumption. You compare it with other year, same month, or the other month. Okay, so how does one site in a multi-site operation compare with another? Okay, so if you have different different na mga areas of location of facilities, you compare these facilities with the other facilities location. You know, how do they consume energy? So you compare. You see the difference, no? Whether really you are consuming a lot of energy, you are efficient or not, based on this comparison. After comparing, number three is to understand when the energy is used. The cost of electricity is influenced by the demand and the time of use. So yung kanina, so understand when do you use much of the energy? Is it night? Is it what particular time of the day? No? Do you use energy? Do you use electricity? Okay. Number four, understand where is it used. So treat energy as you would any other purchased products. So where? Paano ba siya ginagamit? How is it? Uh, what particular usage is that? No? Is it essential usage or not? So those are the things that you need to question where it is a correct. No? Number five, you match usage to requirement, the duration of use and the magnitude of use. Okay? So try to compare whether gaano ba siya katagal ginagamit. For for that particular equipment. For example, the details, no, what particular equipment, how much time do you use that one, no? Your light, for example, if you're in a building, how many hours in a day you use the light, no, the magnitude of use, your aircon, no, in a facility, uh, how much hour do you use, what temperature ba yung ginagamit niyo for your aircon in the facility, ilan bang tao, or what area ba, is it ganun, parang ganun. Those are the questions, no? Number 6, maximize systems efficiency. So the impact of operating conditions, maintenance, and equipment technology will be considered. So here you try to see uh, whether are you maintaining, do you have the maintenance plan with your equipment or your technology, what are the operating conditions, no? So those are the things that we need to consider in this step number 6. And step number 7, optimize the energy use. So heat recovery systems, alternative tariff structure, no, alternative fuels, or even larger measures such as cogeneration or combined heat and power cycle systems can be integrated. So this one is you optimize na, no. You try to see na these are the things that we need to consider. These are the things that we need to do. So yeah. So those are the things that we need to do. The 7 steps in doing this energy management. Okay. Now, to do energy management, first is to do the energy audit. We cannot do energy management if we are not going to audit our facilities. So, next time na stage natin is to do the energy audit. Go details ano? Paano ba gawin from the perspective of energy management, we go to the detail of energy audit. Paano ba gawin si energy audit for a facility? So, energy audit is a systematic procedure wherein verification, monitoring, and analysis is used in the use of energy. So yung kaninang sinabi natin ng mga steps to when do you use, how do you use the energy, kasama na yun yung energy audit. Makikita yun yung energy audit. So you verify, you monitor, and analyze the use of energy. It includes a technical report, no, the cost benefit analysis and actions plans to reduce the energy consumption. So that's the process of energy audit, process of evaluating, identification of saving measures, and reporting. So in energy audit, there are of different properties, no? So you start with the scope. What will be the scope of energy audit that you're be doing? You try to ask yourself, is it a narrow audit, specific system or area, no? Specific system ba or specific area lang ba? Or if you are a large facility, are you doing energy audit for just one area in your facility? Isang floor lang ba? Parang ganun? Or isang office lang ba? Or a wide? Is it an every system or all site? No? Whole site ba? Lahat ba? No? Whole building? No? In our university, for example, is it a whole campus? Are we doing a whole campus or whole one? If narrow, that's one building lang. No, this thing. The scope. Another one is it. What's that? The thoroughness of your audit. Is it a rough comb, meaning general potential assessment? No, rough comb, or a fine comb, meaning detailed potential assessment. That's what you want. You want to see how that the details of everything. No? And lastly, the most important thing, the aim. What's the purpose? What's the purpose of your doing your energy audit in the sense? No? First one, is it the general energy saving areas lang ba? To point out the general energy savings, or to purpose specific energy saving measures. So depending on the aim of the particular energy audit. Okay? So advantages of Energy audit is that it promote awareness in energy efficiency, no, in your facility. It identify the cost of energy you use, identify and minimize wastage. What are those uh, wastage in your facility? No, are we wasting energy? Are we wasting electricity? Making change to produce procedure, equipment, and system to save energy. No, what are those changes that we need to do to save energy? Retrofit energy efficiency technologies. Conserve non-renewable energy resource. Okay. Protect the environment by reducing
Taylor.
power
Nara
generation.
dire sir. Ay, open dia. Ay, nada-open dito, sir.
Sige sa cell, marag na ay naka-on nga mic. Okay. Then you reduce your running cost. No, the running cost. So those are the advantages. So procedures for energy audit. The first one is the pre-audit stage. So in the pre-audit stage, before you do the audit, you need to define the scope of the energy audit. Yung kanina na sinabi ko, no? What are the scope? You form the energy audit team. You estimate the time frame and the budget, so depending on the purpose and depending on because the purpose, what's the purpose of energy audit that you're doing. So that would dictate the time frame as well as the budget, depending also. And collecting building information. Those are the pre-audit stage. And next one is the energy audit stage. This is where you conduct the site inspection and measurement. No, the actual measurement. The narrative is to analyze the data collected, and you prepare the energy audit report. Then the last stage is the post-audit stage. Therein, you implement the energy management opportunities that you identify, the EMOs, and number two, the monitoring and review. That's how you do the energy audit. No, so let's start with the pre-audit stage. So in the pre-audit stage, we define the scope of the energy audit. Now, in the scope of the energy audit, it's important to involve the senior management, the facilities operator, and the staff in determining the scope of the work, because they are, especially the staff and the facilities operator, because they are the one na as a field, no? So the scope of work and the available resources for the conduct of the energy audit, because they know what is in the field. So it's important to involve everything, not only the senior management, but everything on the ground should be involved in this, in creating the scope of the energy audit. Another one, and the scope of the work includes the areas to be audited, the level of sophistication of the audit, the saving anticipations, and the need of improvement on the O&M and the needs for training, maybe. No? So, yun yung specify natin sa scope of work. And, syempre, the available resources, meaning the staff, the time, and the budget. Who would be involved here? The time, how long we'll be doing the energy audit, and the budget that we need for the energy audit. Okay, then after that, if you're also have the scope already, okay na, then you create the team. The team of the auditor form the audit team. So the number of auditors depend on the scope. So depende siya sa scope and the objective of the energy audit. So the duties of the members of the audit should be defined. So it should be clearly defined. So uh, for the audit, and the auditors are competent person having adequate knowledge. So hindi pwede na, example, you are only auditing the building that on electrical area. So meaning the people that the auditor should be on the area of electrical engineering, or you're going to the holistic way, the whole building specifically. So you involve all the people, the audit team that has knowledge for particular energy. For example, in the case you need to have electrical engineers, mechanical engineers, or civil engineers in that particular area. No, so involving the facilities operators to provide input. Okay, so you need also to involve in the team the facilities operator, meaning those people that operating in that particular na facility. No, they are part of the team. And if it's in-house experience is not adequate, energy audit consultant should be employed. So including university staff can be uh, part of the consultant. No, you can employ energy audit consultant for that case if your existing expertise does not warrant for a particular audit team. Okay. Now the time frame and budget, number three. No, this is based on the available resources. No, the time frame and the budget can be established. So the budget is mainly built up on the cost of the auditor hours. So whether it is in-house or whether it's a consultant that you hire, you try to see based on the budgeting what would be the cost on based on the number of hours of these auditors in your facility. The number of audit hours is depends on the degree of sophistication required by the scope of audit. So the detailed audit can have auditors hours that are above 5 to 10 times than required by the walkthrough audit. So imagine uh, if you need a very sophisticated audit, that would be a much more time, 5 to 10 times than the walkthrough audit. Walkthrough audit was much simpler because you're going through. So the audit team should check if adequate testing instruments are available and the cost of purchasing additional instruments should be added. So that's part of the budget, the instrument and the tools needed for these auditors. No? In addition, the cost of employing consultants should be included if so required. So if need consultant, you need to put it in the budget in the prime print. Okay. So number four, collecting bad building information. So before you do the audit, you should have the information of the facility. What are those? The general building characteristics such as the floor plans, the number of occupants, the hours of occupation, the details of the building elements, orientation, etc. All of those things. The technical details of energy consuming equipment system, whether they have aircon there, you need to get the details of each of those before you do the audit. The design report with system schematic diagrams, layout drawing, etc. Equipment, system operation records, including data log sheets, etc. Record of energy management opportunities if you have already implemented energy management or energy audit before. No? Operation and maintenance manuals, NTC technical manuals. No? Energy bills. No, this is very important. The bills, if you want to reduce your electricity usage, electricity, fuel, etc., for the past 3 years. No, past 3 years. Okay. So, what are the things? The audit team should determine the appropriate parties to be approached for information collection who are involved. For example, you have a multi-facility. You need to do the multi-facility. So, the audit team should know who are those in charge of that particular facilities. The need to discuss with these parties for formalization of the building and the equipment systems. Okay. Now, the audit team should consider issuing questionnaires to end users to collect information on the thermal comfort, lighting comfort, operational hours of the offices. So as much as possible, before you do the audit, you should naka-prepare na yung questionnaires natin. No, what are those questionnaires that need to be asked to your to the people inside the facility who are the using that particular facility? You need to create that questionnaires before you do the actual audit. So okay. So at this stage, the audit team should be able to tell the characteristic of the energy consuming equipment system, such as the type of chillers, their capacities and characteristics, the type of HVAC system, their component and characteristic if they have HVAC system, occupancies or usage for various systems. So what is the usage of this particular room, the usage of this particular building, no? The control device for various equipment systems, the type of luminaires, no? Because it is in the plan, no? Their characteristic and the control mechanism, the power distribution system characteristics, no? The operational characteristic of elevator and escalator systems, and the characteristic of the building. So meaning, before pala ng actual audit, dapat meron ka ng information talaga ng whole facility. Alam mo na, nakastudy ka na anong, what is the usage of that particular building, the facility, etc. Okay, what are those equipments in that particular facility? So you need to get the information first before you do the actual audit. Okay, based on the data, you need to get all the data of information on that particular facility. Okay, so next thing is the energy audit stage. So this is where you conduct the audit, the inspection, the actual inspection. No, they analyze the data collected. So and they're preparing the energy audit report. So first is the site inspection and measurement. So in doing the site inspection and measurement, ito yung medyo matagal no because you're going, if you have a large area, you need to go to that particular area. That's why it's better to have a team in this particular event, no? So you plan the site inspection for areas and equipments to be investigated because you already have the information naman, no? So you can plan out what facilities that you're going to visit first, what particular equipment that you're going to inspect first. Are you going to inspect first the facility based on facilities, or are you going to inspect first based on equipments? You have to decide, no? You allocate the work among your auditors, no? Whether you need to ano bang task each auditors na. If you are electrical engineer, so example, you will be tasked for this particular area. Mechanical engineer, you will be tasked for this particular area. No, you develop the energy audit forms to record the findings. So you need to create the forms, no, for the energy audit based on this equipment that they have or the facilities that they have. So you plan ahead on the site measurement to supplement or verify information collected. So since you have already the information, that's a time in the inspection that you can verify whether is this really the actual sense, no? So the measurement should focus on equipment systems that inadequate information is available. So those are the things that we need to do. So inspection of building and plants to identify obvious areas of wastage and energy management opportunities. So these are the typical areas included. So these are some of the areas that yung pwede nating unahin, no? These are the usual common thing. The running hours of the AC system, the aircon, no? In a day, how much time does it run? The running hours of other system equipment, other system or equipment, the length of AC pre-cooled period, okay? The control set point of above system equipment. Okay, example, your aircon. Ano bang set temperature na ginagamit niyo for a particular office or particular building? Anong set point? What time of the day? Are you turning off your aircon of a particular time of the day, or is it turned on the whole day? Ganun. Those are the information. Internal control condition. No, the temperature, the RH airflow rates, the lighting level, those are important thing. That's why you need the instrument. Water temperature if needed, no? If you have in the industrial facilities, no, doors not properly closed. Okay, you need to identify those things. Curtains or blinds not provided in AC areas, no. Locations where AC and lighting are unnecessarily provided, no. Those areas that are heavily lighted, that sobra na siya, or those areas that are less lighted, or those areas that has vast amount of air conditioning. The use of energy inefficient lightings, no? Improper positioning of thermostat and switches, abnormal water consumptions, no? Adequacy of insulation of building fabrics. Okay, that's why you need also in the team the architect or uh, civil engineers. The amount of waste heat discharged from equipment that could be recovered, and the areas of high energy consumption and the opportunities for improvement. So those are the things that we need to include in a typical uh, plant or inspection, no? Inspection and measurements. So during measurement, the sensors should be located at point that can best reflect the need or functions of the controlled parameters. So you will be bringing your instrument, etc. So you need to see, no, what are those points that you need to test or to measure in that particular area or the particular facility. So if provisions for measurements are absent, the auditors may have to install test holes and plugs or to use ultrasonic type of meters in the areas. So if it's needed, no, parang wala nang choice, no, to measure something in a particular facility. So if the measurements are not practical for use for some systems, the auditors may have to refer to the characteristic curves graphs from the O&M manual. That's why you need the manuals to see whether it is really performing well. Okay, so here are some required instruments if you are going to do the energy management or energy audit. Uh, those are some are those the speed instrument. The first one is the tachometer. No, is in audit experience, speed measurements are critical as they may change the frequency, the belt, the slip, and the loading. No, so example, if you are in a production area, so you need to use this tachometer or stroboscope to identify whether the particular rotating machines are rotating, are functioning based on its RPM set. No, so and the frequency. So a simple tachometer is a contact type equipment which can be used where direct access is possible, or we have also other non-contact type, actually, no, non-contact type tachometers today, digital tachometers that you can put in. More sophisticated, safer ones are the non-contact instruments such as stroboscope. Also, we have the leak detectors. Those are ultrasonic instrument available which can be used for detect leaks, no, especially for air cons, no, ACs, no, uh, and other gases which are normally not possible with human abilities. That's why you need the leak detector. Whether there are leakage, especially if you are in the industry that needs vast air conditioning system, so you need to identify whether there are leaks in the particular areas. And to test the illumination level on a particular area, you need the lux meter. The lux meter determines the illumination level uh, in a lux meter. So it consists of photocell which sends the light output, converts to electrical impulse which are calibrated as lux. So there are standards on a particular area. No, example, if you're in an office, you have a different lux standard there. If you are in the production area, you also have a different. So you need to bring lux meter whether you test for you need to do the audit. No, you need to identify whether this particular area is really at its standard or may mga problema ba. No? So another are those electrical measuring instruments that measure for measuring major electrical parameters such as kVA, kilowatt, power factor, hertz, kvar, amps, and volts. Usually, we do is the power quality meter, PQ meter. That is very useful, especially in identifying the harmonics for the area. So those instruments are applied online or on running motors without any need to stop the motors. So, or a very simple one, multi-tester can be used in when you do the audit. Simple lang, no? Just to test whether the voltage level is it okay in a particular site for the current, etc. So instant measurement can be taken with handheld meters, while more advanced ones facilitates cumulative readings with printouts at specified intervals. So depending. Another one is for yung sa mga plants, ano, mga planta na, and as well as in the production, the combustion analyzers. This instrument has inbuilt chemical cells which measures the various gases such as carbon dioxide, CO, nitro oxide, and sulfur oxide, etc. Then for fuel, this measures oxygen, the fuel efficiency monitor, oxygen and temperature of the fuel gas, calorific values of common fuels are fed into the microprocessors which calculates the combustion efficiency. Aside from that, we can also use the Fire. A handheld below pump draws the flue gas sample into the solution inside the Fire. So a chemical reaction changes the liquid volume, revealing the amount of gas percentage oxygen or CO2 can be read from the scale. So that's another thing. But for electrical engineers like us, we usually use the electrical instruments, the lux meter, yung kanina, and this speed meter, the tachometer. Those are the things that we need to bring. Another one is the contact thermometer. If you want to measure the temperature, whether in a particular area, to see whether these are thermocouples, which measures, for example, the flue gas, hot air, hot water temperature by insertion of proof into the stream. So yun yung sa mga plants. No? So another one, the infrared pyrometer. No? So these are non-contact type measurements, which when detected a heat source, yun yung actually ginagamit natin ngayon. No, parang binabaril, no? uh, Heat source directly gives a temperature readout, can be useful to measure hot jobs in furnace or basic temperature. Other is the manometer and the pitot tube for air velocity, and ducts can be measured using pitot tube. And one is the ultrasonic flow meter. No, so this flow meter is a non-contact flow measuring device using a Doppler effect principle. This is a transmitter and receiver which are positioned on opposite side of the pipe. So the meter that directly gives the flow, water, and the fluid flows can be easily measured with this meter. So those are the things that we need to. But as electrical engineers, yun lang mga basic for electricals. Okay? So with all of that, number two is analyzing the data collected. After gathering the data, gathering the information, gathering all the measurement, next step to do is to analyze the data. So based on the information collected, the audit team should screen and spot the parameters with values and trends that deviate that would be anticipated. Okay, so that debate the standard, that debate the supposed to be level in a particular site or particular facility. So these are the potential energy management opportunities. Example, EMOs are improvement works that save energy and investment can be repaid by saving in reasonable time. Now, however, they should take into account the analysis of the irregularities caused by change in occupancy, weather, or other activities. So you need to see that also. No? So to identify the potential EMOs in our energy management opportunity, calculations should be performed, qualifying energy savings. So you need to quantify. That's why you need to gather information, the supposed to be plan of the particular facility, the actual using in the pre-audit, you need to get the information of the facility. In the actual audit, you need to see the actual in such a way you can calculate what is the performance, no, of the particular facility and identify that what are those energy management opportunity in order to calculate uh, the savings for that particular facility. So to evaluate the effectiveness of the energy management opportunity, the auditor has to calculate the payback period, those economic uh, mga parameters na kinakalculate natin, no? The payback period, the net present value, or the rate of return, or sometimes what we call the life cycle cost assessment, no, may have to be performed for that particular facility. So the EMO should normally not downgrade the quality of the service to that below common design standards. Okay, so they should follow the standards. So it is important to maintain good thermal comfort, lighting comfort, and adequate supply of fresh air in that facility. So that those are important things that we need to consider. So it is always possible to improve energy efficiency, at the same time maintain or even improve indoor air quality. Okay? So yung mga important thing in analyzing the data, no? So when determining the energy management opportunity or the EMO, it is necessary to take into account the scheduled major maintenance work. Okay? So tingnan mo yung records ng maintenance nila, what are the spends and maintenance work. So this reduce the cost accountable to the implementation of the energy management opportunity. So because you can actually uh, use the maintenance, no, maintenance schedules in doing this energy management opportunities in your recommendations, no? So the auditors should produce the following for use in the audit report. Una, the graph of various energy consumption against the month, no? Graph niya ng history ng energy consumption ng month nyo. So you compare, or yung sabi kanina na comparing the facilities, no? So you can represent it in a graph or in a pie chart, etc. You can do that one. Charts of different proportion of energy consumption of a building. So yung kanina, no? You can have a pie chart, the bar graph, you can do that one to represent the energy consumption. And energy utilization index on that particular facility. Energy per meter square. Okay, so data collected may have different units, and it's useful to use the following conversion table to facilitate the comparison. So these are some important units and comparison. So electricity to megajoules, dependent, it's actually depending man kasi dun sa equipment, no? Ano yung nakalagay na nameplate. So that's why important yung conversion natin ng mga factors. If you want to convert to megajoule, 3.6 ng town gas, 8 LPG, diesel fuel, petrol fuel. Those are the things. For us, electricity, for megajoules lang, kilowatt hour. So, number 3, the energy audit report. Ano bang nasa loob ng energy audit report? So, the first part of the energy audit report should provide us the executive summary. This provides the building management quick overview of the status of the scope of the audit, the energy management opportunities identified, recommended actions justified by savings and implementation plan. So parang it's like a summary. If we are in a book, it's like an abstract of everything. No, the first part. After that, the introduction. Inside the introduction, the first part is the building being audited with characteristic of the building, schematics, layouts, and appendix as appendix. No, so those are the things. Objectives. So just like writing a research, no, objectives, the scope of the audit, and the audit team. Syempre, no. So those are the things in the introduction. So what building facilities are you auditing? What are the characteristics? You have already those data man in the pre-audit stage, schematic, etc. You can put it in the annexes, and objectives. Okay, what the purpose of your audit and the scope of audit, and the audit team, who are those involved people. Okay, then next is the description of the equipment systems. So the zoning of the system according to the building height or usage, that in the report. The HVAC installations for different areas. So lighting installations, no? Electrical installations, elevators and escalators installations, the plumbing and drainage systems, no? If you're going to go to details, no? Hot water systems and other energy consuming equipment systems. So those are the equipment, no? That's part of the the report, the description of the equipment or the systems. Then the next part is the findings. So this part aims to focus on the description of the results of the site inspection. No? So parang what are those things that you have identified? No? This part focus on the description, the result. No? What are those energy management opportunity you have identified based on your audit? So findings in a schematic format, such as in order of system or order of floors or in order of usage. So depende siya yung arrangement. So you put there the description of the areas with special requirement such as 24-hour operation, no temperature, etc. Calculations on the cooling load, lighting load, electrical load, annual energy consumption with detailed calculation in the appendix. Findings on the operation and maintenance procedures and practices, and the preliminary identification of the AMOs. So those are the things that you put in the findings. Okay. So next dion is the analysis and identification of the energy management opportunity. So how do you analyze? First one is you comparison on the actual performance of equipment or the system against the original design and identify cause of any discrepancy. That's why you need in the pre-audit, you need to get the information of the facility in order for you to identify ano ba yung problema in the actual, no? In the actual audit. Number two, the possible energy management opportunity and uh, substantiations. So detailed calculation in the appendix, no? Number three, implementation cost of the EMO. The detailed calculation is in the appendix. So number two, what are those EMOs? Number three, what's the cost of the EMOs? Does it need a cost or not? Okay. Comparison of different solutions to the same EMOs. Okay. Classification of the EMOs into categories. So what are those categories? No? Ano ba itong category ng mga energy management opportunities natin? No? Listing of all EMOs in the systematic format, as in order of the system. No? Investment and payback of the EMOs. No? All of your energy management opportunity, what are those payback period, investment, etc. Difficulties that may encounter in the implementation. The program for implementation of the EMOs. Ano ba yung first phase, second phase, third phase, parang ganon. And the areas for further study, if any. So those are the important things that we need to put in identifying the energy management opportunities. Okay. So lastly, in the audit report is the recommendation. No, the recommendation part should be made in a systematic order, meaning naka-arrange siya, ano ba yung energy management of number one, number two, ano ba yung categories nito, and ano ba yung cost nito. So grouping items of similar nature, location, usage together, grouping according to their categories, category 1, 2, 3, and initial investment and payback should be highlighted here again. So ito na yan, no? So here is an example of an energy management effect. So just like this one, no, you can have it represented in a graph na ganito, no, na it's like a graph that the first stage is you do the enhancement of the management in this stage before you reach this stage, no, the facilities and food change. Facilities and process change. No? So the first stage is you go to enhancement of your management, then the facilities and process change. Under this is in these stages is the management technologies, the audit and improvement technologies, and the process technologies. So you can also represent it in terms of colors, parang ganito, no? This part here has an investment is small, around 11%. Ay, ang kanyang effect. And here is investment is medium, and here is investment is large. So parang ganun. Okay? So no, ito na yung mga categories ng energy management. Okay? So for category 1 EMOs, these are EMOs with no cost implication or small investment. The effect is usually around mga 11%. So these EMOs are usually on behavioral change. Parang it's a policy lang. Change in policy. Like for example, when you in a facility, no, parang in a facility when you identify na uy, may problem in how they use the air conditioning, the lightings. So you just have to do some policies in usage of the aircon. Example, the temperature level should be at this particular set point, and the time of usage, no, at this particular time uses only. Those are the things that you need to put in this EMOs. No, that's why it has no cost implication. No, and usually this is the first stage that you will do as we go through the energy management procedure in your facility. Then the category 2, these are EMOs with little cost implication or medium investment that you put. No, it's just like changing your lightings from non-LED to LEDs. Those are the one, and then little cost depending on your facility. No, and the effect is around 7%. The category 3 are EMOs with significant investment or large investment. That is around 5%. So ito yung mga category. So it does not mean that we need to go first to go all the stages in one glance, no. You need to have this in stages. Like for example, you go first to stage 1, category 1, EMOs lang tayo muna. Then after that, when the policy is okay, then we go to stage 2, and after that, if it's okay, then we go to stage 3. Parang ganun. So samples of EMOs in category 1. Example, correct air water flow rate, switch off fittings in vacant areas. Those are just behavioral change. Delamping, no? Close doors or windows, no? Those are part of you can recommend, no? Your recommendation. Check fresh air dampers. Switch off elevators and escalators during off-peak period. No? You can put that as one of the recommendation. Adopt natural or mechanical ventilations. Okay. Implement housekeeping measures. Notices, no? Promotional activities schedule operational hours, no? Check water leakage and air leakage, no? Clean of luminaires. So parang you notice in the area na parang kulang yung light intensity because the luminaires are very dirty. Just change the behavior, just clean the luminaires. Set thermostat. Ito yung kanina, no? You need to set the temperature level on your AC. Top up refrigerant and compressor oil. Okay, lower lighting level for bright areas. So maybe when you identify, you go to the area na masyado siyang highlighted, na naka-open pa yung mga windows, so naka-on pa yung mga lighting. So those are the things you may put in the category 1 EMOs. Okay? So in the category 2, ito na yung mga may little investment. Example, install blind curtains, air curtains for automatic door, self-luminous exit line signs, and additional switch and controllers. No? Replace incandescent lamps with compact fluorescent lamp or LED. No? Replace electromagnetic pallets. No? Sealing of building leakage. Plant trees near curtain walls. Those are we can consider in our EMOs category number 2. Efficient energy efficient use office equipment, no? Replacing damaged insulations, occupancy sensor, no? If you want it to be high tech na, no? Parang You put time switch, okay? Reprogramming of CCMS, daylight sensors, setback CO2 sensors, harmonic filters, and power factor correction device. No, those are category 2 AMOs. In category 3, ito na yung mga high cost na. For example, recovery, waste, or heat coal, air, thermal wheel. Okay, those are including heat pump, automatic condensing cleaning, modernization of old fits, old lifts, no? Mga old na mga elevators. You replace that one. For our case, example, you you modernize, you replace your old air conditioning unit, no, with this inverter air conditioning unit. That's our category 3. So then the green initiatives that enhance in corporate image, like for example, using of renewable energy in your facility, replacement of ozone depleting refrigerant. Those are the things that we need to put in. Category 3 also is the installation of T5, T8 in electronic with electronic ballast, building management system and software enhancement. That can be new chillers with high COP, water cooling system with cooling towers, uh, high efficiency motors, no? Use of VSD, water saving taps, and low volume water closet. So those are categories na mga sino. So those are sample of each in the category. So from you can put that one in your report, no? Just like a recommendation for you can put the category 1, this will be the recommendation, specific, category 2, ganito. Okay? After that, then you go to the post-audit stage. The post-audit stage is the implementation of the energy management opportunities and monitoring and review. So, number 1 is the implementation of EO. So, self-funding, for self-funding, this will harvest the biggest benefit, but the organization must have initial funding. Okay? Biggest benefit, but you need, if you're an organization, dapat meron kang initial funding. So, energy service companies can be employed to carry out the implementation of energy management opportunities, but that needs investment, no? So, or energy performance contracting, using the same energy cost to finance the energy efficiency improvement work. You can also do that one. Need for fair contract and protocol for verification of energy saving and successful cases in hospital and university. So those are things that you can do to implement the EMOS. So it can be self-funding if you have budget, no? You can use energy service company. You can hire them, or performance contracting. No? So you just utilize the savings to finance your energy efficiency improvement in your area. Okay, so here are the common findings for energy audit that we have. So example, for category 1, next for example, you categorize this as for HVAC, EMO category 1. This one, AC remain on site of on outside office area. So based, that is your observation, no? That the air conditioning remain on outside office area. So what are those recommendations? The last man out to turn off AC or install time switch. Unnecessary consumption of energy. Those are your recommendation, no? Another one, AC remain on for unoccupied areas or redundant areas. So same, the last man out to turn off AC or install occupancy sensors. Unnecessary consumption of energy. So door or window left open when AC is on. So simple lang yung EMO. Closed door or window. It's around 5 to 20% savings. Okay? Too cold in summer. No? The room temperature is at 21 degree. So set thermostat to 24 degree centigrade. So that's the comfort level, no? So 10 to 30% savings. Excessive pressure drop across filters. So clean filters lang yung energy management opportunity. So 5 to 20% saving in fan power. Chilled water at 6%, 6 degrees centigrade outside summer. So reset temperature to 8 degrees centigrade. So those are just simple things. No? 3 to 6% saving of chiller power. Automatic control overrides by manual control. So what will happen? Just disable the manual control. 10 to 15% saving. Excessive ventilation. Adjust fresh air dampers. So that's 5 to 30% saving. So this is for HVAC, no? HVAC for category 1. But for category 2 na siya, so observation number 1, no blinds or blinds not closed for windows. So simple lang, install or close blinds. So 5 to 30% saving to offset solar heat gain. So access door of each HU or duct has leakage of say 3%. So rectify leakage 3% of fan power. So excessive water leaving duct pump gland, no? So replace stopping box with mechanical seal. Overcooled spots due to improper air balance. So add damper if required and balance the system. So overcooled spots due to improper water balancing. Add valves if required and balance the system. So lack of individual control, add controller. Yun lang, no? Building leakage, rectify leakage, poor maintenance, maintain system, improve maintenance procedure. So those are the category 2. This one, another for category 3, no? For HVAC na group. So if identify that equipment operating beyond their economic life expectancy, so you replace that with energy efficient equipment. It is 10 to 30% savings. Inefficient air-cooled chillers. So replace with cooling tower with water-cooled chillers. So outdated control system. So install a building management system. Airflow controlled by inlet gains valve. So install BSD. Chilled water pump installed by constant speed motor. So install BSD. So those are uh, for HVAC, no? For lighting installation, these are the things. Example, lighting level too high. So if it is category 1, just put there disconnect power supply to some fitting. That would mean a 15 to 30% savings. Lighting along window areas turn on at daytime. So that's one of the observations. So turn off perimeter lighting. That is 20 to 30% savings. Lighting remain on outside office areas. So last man out to turn off lighting or install time switch. So unnecessary consumption of energy. Lighting remain on for unoccupied areas. So same light last man out to turn off lighting or install occupancy sensors. Lighting remain on for redundant functions. So remove the unnecessary lighting. So that is unnecessary consumption of energy. So those are for the lighting category 1. No, for category 2, for lighting, here this example, no, observation T12 and T10 fittings used in the lighting. So you replace it with T5 lighting or LED, no, 30% savings. T8 fittings used in lighting, so replace with T5 fittings. Manual control for lighting, install occupancy sensor. Incandescent lamp being used. So replace with LEDs na ngayon, no? Yeah, ngayon, no? Hindi na compact fluorescent lamp. Not enough lighting. Control switch. Install more switches. So about okay. For category 2 and 3, no? Another one is oversized motor by 30%. So replace with smaller motor of proper size. Okay. Overall power factor is 0.8, so improve to minimum of 0.85. So minimize loss of the network. 30% total harmonics distortion. Add harmonic filters to reduce HD. So minimize loss to the network. So power supply tariff is not favorable. So conduct tariff review and apply to supply company for a special charge rate other than general tariff. So those are EMO number 3. Okay, so those are the forms of the common findings. Okay, for number 2, under the post audit, so the monitoring and review. So subsequently, to implement the implementation of the EMOs, the audit team should monitor the energy consumption for at least 1 year. No? So 1 year siya na monitoring to verify the predicted savings. So you have identified man what would be the savings if you implement this particular recommendation. So you need to monitor whether is at reach that particular level or not, no? And what are the causes why it does not reach that particular level, no? So any discrepancies should be analyzed and corrective actions shall be taken, no? Success stories should be recorded, no, and used to justify future energy audit recommendations. So follow-up energy audit should be carried out about 5 years after the first audit. Okay, so meron siyang talagang periodic audit na ginagawa for energy audit. Okay, so next is that I will be sharing to you our experience regarding USTP's energy audit and energy management practices that we have in the university. Okay, so here is a graph showing us here 900,000 to 1.6 million. What is this? This is actually the energy, the cost of electricity that our university has from 2014 to 2007. Okay, so imagine we have that increasing trend from 900,000 to 1.6 million. No, that is 2017. I don't know today. No, from 2020 it could be 19, 2020 that could be bigger. Okay, so that's why in our university we have this study on the development of energy management policy in the USTP, University of Science and Technology of Southern Philippines. So as a background, so this is the definition, no? The energy management is defined as a process of monitoring, controlling, and conserving energy in a building. So adopting energy management can be a solution to increasing demand of electricity. Now, typical major cause of energy consumption in the building includes lighting, air conditioning, and the use of electrical devices, equipment like computers, appliances. So these are our typical load in the university. We have lighting, air conditioning, computers, and other equipments used in the laboratory. An improper use of such appliances and devices could increase the energy consumption of particular institution, like us in the university. So this is our bill, no, from 2014 until 2017. Taas na agad ang trend. So, and our annual total electricity bill, no, that is monthly. Ito yung kanina, yung monthly ha, monthly yun, 1.6. But if you're going to total the annual, we are paying in 2015 this much 11 around 12 million, no, for 2015, and in 2017 we reached actually around 16 million uh, uh, total bill, 16 million pesos in a year paid by university. No, so imagine that much. If we can save that particular energy, we can actually, from our management point of view, we can actually use that one for other use in our university, no, for our students. So that's why we opt to this study to determine what are those energy management opportunities and what would be the savings if you're going to do this energy management opportunity. That's why. So why do we have this much of uh, electricity in paid in our university? Because how many electricity bills does a USTP receive every month? The university actually during this time 2017 we received 5 electricity bills per month because we have 5 metering points in our university. No, that's why today we are proposing, part of the recommendation is to have uh, one metering point in the university. That's one of the proposal that we have in our recommendation in aligning with this energy management areas. So imagine we have these five bills, no, and that's one of the reason also that we have this large amount of bill because our demand factor is that common, nakaseparate siya. So uh, based on this, we evaluated the bill, no, in this area. The average annual energy consumption per meter. So we have these 5 meters, 5 bills. So we identify, no, the contribution of each metering points. So we identify here that this bill number 13 13966,903, no, has 31% of the whole kilowatt hour consumption. That's why it has also the annual peak demand also is uh is 27% based on this bill. And the lowest, yung pinakamaliit na billing point namin na metering point is this 119,61607, that is 9%, no? That is having also uh, 65 kilowatt na peak, no? That is 7% in our peak namin. Okay? So what we did with this observation. So we did a load audit in each building of the university. So we conduct interview, we audit the building, we go through, we create the team, no, with the faculty and students, we create the team and do the energy audit in the university in CDO campus. We conduct interview for the purpose of determining uh, the usage of the facilities inside each of the rooms, no, mga offices in these different buildings. So we do also, aside from the interview, we created also the forms, no, that they need to fill in uh, for the usage of the building and the facilities. What are those equipments that they have inside that particular areas? Okay, and aside from that, we already gathered naman the information regarding the building. We gathered the plans, etc., of these facilities. Then we analyze the load audit reports. Okay, so analyzing then the load audit results. So based on this, the load audit results provides us this information. We do the audit, etc., and we have this result. Based on this result, 54% of our load, no, is coming from air conditioning. Okay, only 9% is lighting, and 37% is other equipment. This other equipment includes our laboratory equipments, our computers that we have in our university. Okay, so parang if the EMO will tell us, if we want to reduce our electricity usage, we should focus on the areas of the air conditioning because that forms part of the largest part of the load that we have in our university. We also have this analysis on the load distribution of each building, of the building. So we identify here that the ICT building namin has the largest load throughout the whole university because the ICT has the most number of air conditioning because that is the main server is where you can find, as well as the laboratories are already there, the computer labs are there. That's why it has the largest load, followed by the learning resource center. That's our library is located, no? We also have there the a library, and some of the laboratories in that building are also found there. That's why it has a large number of usage of air conditioning and other loads, and the ITB building also, which has uh, also the other laboratories that we have, followed by the engineering complex, the building 42 and 43, which has the engineering laboratories and the elevators. No, this science complex, the engineering has elevators that consumes energy also, and the offices are also part of those facilities of those building. That's why it's large. But the largest one is the ICT. Okay, and here is a analysis of the air conditioning load. So the same, no? We identify here that the ICT has the most load in terms of air conditioning, followed by the ITB and the Learning Resource Center and the engineering, specifically building 42 and 43 and the psycho. Those are the uh, buildings that consumes large load. In terms of lighting, our gymnasium, no, our gymnasium is the one has the large load. No, in terms of load of lighting load, our gymnasium, followed by the science complex and the ICT and the ITP building, then the engineering 42 and 43. So those are the uh, large load in terms of lighting. And for other equipment, yun na, no? Si ICT din yung number one because it has all the computer laboratories in the university. So followed again by the furniture shop that we have because it has also the laboratory for large motor loads, no? Yung mga laboratory doon. And the ITB, and followed by the engineering complex B and A. Okay, so what we did is we developed an energy management policy. We developed it by phase. So the purpose of the energy management policy is to observe as a to serve as a driver to improve and promote energy efficiency and conservation at the university as a simple policy listed below. So we created it into 3 action plan, phase by phase, phase to phase. This phase actually is based on the category that we have in the energy audit, the category 1, category 2, and the category 3. So phase 1, by yung mga phase 1. So the phase 1 in energy management action plan is an immediate response which can be performed in the school year. The phase will be focusing on the existing system and practices in the institution that will have a greatest conservation impact with minimal expense. So yun yung first category. Such as changing the behavior and practice of the users, establishing new protocols in using the facilities, equipments, and educating employees and students about the importance of energy conservation and management. Then the phase 2 is the energy management action plan. It's a long-range response which can be performed by the next year. This phase will require funding by the institution for the acquisition of energy-efficient materials, contracts for retrofitting, replacement of old and inefficient products, supplements of existing budgets, or additions of changes to statutes and regulatory policies, etc. And phase 3 is the energy management action plan corresponds to monitoring and reporting and execution. Wherein this includes performing load audit, quarterly monitoring of the energy consumption each month, quarterly and year reports, financial savings, and evaluation results in order to achieve the phase. It is recommended to hire energy management manager. Energy management manager monitors the use of energy usage across the organization, and also to hire energy auditor, energy management officers, and energy planning official. That's why it's part of the phase 3 because we need to hire this personnel to have this phase 3 na requirement namin. It's a large investment. Okay, so this is the result now, no? The proposed policy, phase 1. So if we are going to have this that in the class light there should be used or only be used beyond the 5 p.m. Use only the natural lighting because as what we have observed, we have a large window in our classroom, in our facility, whenever possible. Turn off light near windows when daylight is sufficient. Take advantage of natural lighting and turn off unnecessary lighting in the classroom. When possible, classroom accounts for 30% of the total load in the university. So that's what that is our observation. If we are going to implement this, no, we can have a maximum saving of about 980,000 per year, no, by just having the phase one for lighting. Maximum lang yan. Meaning 100% all of the classroom will be doing this. No, we have also conducted a sensitivity analysis. Let's say 50% lang gagawin. So we have around 490,000 if we're going to do this. Half lang siya. In turning off light, number two, in unoccupied rooms and stock rooms, because you have observed that there are rooms that are turned on even if there are no people inside, and stock rooms also. Accounts about this is account around 3% of the total lighting load in the university. So if you're going to implement this, we have a maximum saving of around 98,000 per year. So maliit lang siya because it's around 3% lang man, no? So 50% lang yan, let's say for example, that is around 48,000. So in the offices, 50% of the lights should only be operated during daytime. Adequate amount of illumination should be implemented in all offices. Offices around 27% of the total load in the university. So a maximum savings is around 882,000 per year. So yun yung savings namin, no? For aircon, in all offices and classrooms in the university should start operating at 9 a.m. Parang ganun lang, no? Turn on only aircon starts at 9 a.m. Offices and classroom ECU accounts as 95%. If we have this, we can have a maximum savings around 2 million per year. So imagine that savings, parang yung pag-present namin talaga dito, parang yung management namin, no? That's a good investment. No? We can have other projects if we have that savings. No? Fixed temperature setting of air conditioning units should be implemented. The comfort temperature about 24 to 25 degrees Celsius because as per our observation, the temperature setting in the ACU is around 18 to 22 degrees. For every degrees, there's around 3% reduction in the energy consumption. So if we have this maximum saving, we have around 1.9 million per year for just changing the temperature setting on this air conditioning level. So if all in all, by just phase one, if we're going to implement those things, we can be around 6 million savings per year maximum if we are going to implement all of this phase one implementation. So sa phase 2 namin, no? Add pa namin yung phase 2, let's say replacement of fluorescent light bulb, replacement of old model air cons that we have in investment, no? We have a total maximum savings again for this phase 2 if we're going to implement this around 1.9 million savings per year if you're going to do this. Okay, so those are the results. So that's why after this we craft all of the policies that we have and we endorse this to our management. No, so these are the policies that we have, the lightings, whenever possible, yes, natural lighting, turn off yung kanina sinabi ko, no? Turn off all the lights in unoccupied stock rooms. In offices, 50% of the lights should only be operated during daytime. Air conditioning should be start at 9 a.m. Fixed temperature setting to 24 to 25 degrees Celsius. No? For phase 2, replace incandescent lamp and fluorescent lamp into energy efficient light bulbs, LED bulbs. Replace air conditioning unit with already reached more than its service cycle. The service life of a typical air conditioning unit is around 10 years. So we have observed that there are air conditioning and renovations that are more than 10 years already. So we can replace these things. Purchase energy efficient office equipment and computer electronic and monitor to reduce heat output and energy consumption. Continue to purchase high efficient motors of electrical equipment and make use of technology and modernize the facilities. So phase 3, ito na yon, yung large investment, you hire an manager, energy management monitors, and use of energy usage across institution. Perform an energy audit of this quarterly. Monitor, provide safety and energy conservation awareness, and institutionalize energy management in the university. So, it's actually following Republic Act number 11285. No, this is the rule, no? Based on this one, to hire a certified energy conservation officer and a certified energy manager. Okay, so this would be the policies for phase 3 that we want. We created this uh, parang hiring plan, no, for this policy. So what are those people involved? So in conclusion, based on the study, an average of 18% is calculated as the average annual growth rate of electricity bill for 2015 to 2017. And based on the estimation of the potential savings, it involves at about 6 million of the total amount of bill which will be saved by implementing phase 1, and continue will be implemented for we will have additional of 1.9 million for phase 2. So, and institutionalizing the energy management at university is important to proper implementation of continual improvement and compliance. So these are the great potential to reduce the electrical consumption and save if we will implement energy management policy. So this research is just very simple. We just focus more actually on the policy, on just changing the behavior of the people that we want in the university. We can actually improve this by providing other opportunities that we have, like for example, employing renewable energy resources in our university. That could be another study. That's why here are some recommendations to hire a certified energy manager, integrate the energy management in the organization, and establish a separate organizational unit for energy management. So way forward, that's what we are conducting now. We're doing the energy management study 2.0. We go into a more detailed energy audit and energy monitoring infrastructure for energy building in a university, and USTP substation study. We want to do that, and the integration of renewable energy resources. Okay, so I think that's all for my presentation for this afternoon. Hopefully you gain something from my presentation, and hopefully that you are encouraged to do also your part in doing the energy management in your own facility, in or your own building or your own company, such that you can also help not only the company but actually in a bigger perspective, holistic perspective. It's actually a global initiative that we want to reduce our carbon emission. We want to reduce our dependency on this or this fuel fossil fuel based technology, such that we can reduce the carbon dioxide emission, and such that we will not have a problem in the near future. So I think that's all. Thank you, and good afternoon, everyone.
Okay. Okay. Um, Thank you for that very informative talk, sir. It was very comprehensive. No? It's a very comprehensive presentation from our speaker, who I should mention is also one of our former chapter presidents. So I'm sure our participants have learned so much and appreciated the details that go into effective energy management. So I'm fairly confident now that our participants are now better equipped to carry out their own energy audits or employ their energy management strategies in their own workplaces or institutions. Once again, thank you to our speaker, Engineer Rojien V. Morcilla, for that very valuable and enriching presentation. So before we give out the certificate of appreciation for our speaker, um, we will have an open forum. So we'll entertain some questions. So we already have collated some of those questions from the chat box. Now, as we answer, the speaker will answer or address these questions. So I'd like to announce that for our participants, while we're having the open forum, so um, kindly fill up the attendance sheet as found in the chat box. So also the evaluation forms will now be um, distributed also. So kindly find that link in the chat box as well. So I guess Sir Rojien, we can answer this first question or concern. This is from Sir Kennedy B. Morales. Our company is a Type 2 DE, but we are unable to pass the energy efficiency report to DOE on the April 15, 2021 deadline. The company appointed me as energy manager, but my appointment letter was only given on June 4, 2021. So past the deadline. So can you still send a report even if it's too late? Thanks for the reply. So Sir Rojien?
Okay. So yes, sir. Okay. I cannot answer on behalf of the DOE, because this is a requirement of the Department of Energy. Siguro what you can do is actually to ask basically the DOE for some consideration because of the reason that your appointment were just done last June 4, no. So I can answer on behalf that it would be okay to submit late, no. Just ask siguro DOE for this consideration regarding your concern. Sir Don, commute yata ka, Sir Don.
Sorry. So with that, let's move on to the question. Next question from Sir Harry Alan Erasquin. May bearing ba sa EMO ang regular cleaning of ACU? Pag marumi na kasi, mainit ang buga. Tendency, tinatagad ang temperature, pero mainit pa rin.
Yeah.
So a question on
that's
ACU unit.
Yeah. That's a good question, no. Basically important kasi that's when you have an ACU, the maintenance and the cleaning is part of the that you need to do, no. Energy management, that's part in so it's basically it has a bearing on creating the energy management opportunity. So if you identify that the air cons are dirty and they are, because of that sinasagad na nila yung temperature, that can be part of energy management opportunity, that you have to follow the management plan of your air conditioning unit. So that's part that can be part of the category 1 siguro na recommendation if you have the energy management opportunity.
Okay. So another question is from Ricardo M. Sanchez Jr. How is EMO compared to SLR or systems loss reduction?
Okay. We can actually the energy management opportunities is dependent on a particular facility, no. let's say for example, if you are a facility that has that large systems loss, no, in your example, you are a didn't you are a commercial or uh, industrial load that you observe that you have a large systems loss. So you identify what are the causes of those systems loss increase in your facility, and that can be part of the energy management opportunity that you can put in your observations later on. No, so uh, that can reduce your reduction. No? That can reduce the loss of your system. Sige. Kaya na lang.
Okay, so
For number two,
uh,
ako na lang basa sir doon, paano makatulong ang
sige,
pagkakaroon ng
sige sir.
sariling substation, no? For our case kasi sir, nilagay ko siya doon sa way
Maganda nga
forward because that's what we are trying to identify. That's part of our study that we need to because we as what I presented kanina, no, we have 5 metering point in our university. So we have that and we want to combine all of those metering point into one. That's why we intend to identify if we are going to put up a substation that would be better for our university, uh, such that we can reduce our energy consumption, and as well as if we have our sariling substation man kasi, we can actually centralize our loads in our university, such that also we can also reduce basically our losses in our lines, no? So those are the things. So we can actually ngayon we have studies on identifying what would be the optimal location of the substation in our university, that's that we can that would be in the center of the load center, so that we can reduce the losses, we can have power quality. So those are part of of the study. That's why we put that one in our way forward. Yeah. So yung
Okay,
kay Sir
so I guess next.
si Sir Kwan Christian, no? As a person involved in ACU installation, repair, and cleaning, we advise to have regular cleaning for every 3 months, especially if the removed filters are not cleaned weekly. So if the latter is done regularly, cleaning can be done up to every 6 months. So yun yung kanina, no? Dun sa ACU na question. So that's part of the maintenance. So sa experience ni Sir Christian, they have the cleaning is regularly conducted every 3 months. So you need to follow, no? Pag na-audit niyo yung aircon nila, that's part kasi dapat ng ng operation and maintenance ng whole facility. So if you have identified that one of the problem is that they are not following the maintenance plan of their ACU, that to clean it every 3 months, no, that can be part of the EMOs, the energy management opportunity that you can put, and that would mean another savings of the uh, of the facility. Okay. Uh, Another question from Sir Ed. No, in your total load distribution of each building, have you considered the submetering of electricity and water and the return of investment? Okay, have you considered the submetering of electricity and water? So, right for now, sir, we are actually doing a study on putting the meters, no, parang actual talaga yung data namin, because what we have gathered lang man based on our energy audit is based on the survey we have conducted to identify the loads in its building. What we want to determine actually is to do yung sinabi mo na submetering. We want to put meters in each of our building. That's our next step kasi sir. So hopefully sir, we will be doing that one in our electricity, and then we can get calculate now the return of investment, because our previous study man kasi sir is not a study on it's more on policy. So we want to see what would be the savings if you have this policy. So now we are going into the stage of creating this sub-metering in each building in such a way we can identify then what would be the return of investment if we have those actual talaga na data na na parang based on the sub-meters that we have in our building. Okay?
Sir, there's another question from Ricardo M. Sanchez. Which is more efficient, as EMO, a VFD, or soft starter?
Okay. Usually what we do is uh, put in a variable frequency drive. So uh, I cannot actually answer it in based on the efficiency level of the soft starter that we have. But if we are going to siguro on the case that we can compare the two is based on the investment level siguro and type of company that we have. They use the soft starter or the variable frequency drive. No? But in our experience, what we usually do is to use the PFD for production plants. Yeah.
Okay. Uh, so I guess those are all the questions, no? So those for those who are asking regarding the for asking for a copy of the presentation, so those will be a copy will be emailed to you next week, no, by our secretary. Okay. So at this point, we'd like to express our deepest thanks, no, to our speaker with a presentation of a certificate of appreciation. Okay, so I'll read the citation. This certificate of appreciation is presented to Rojien V. Morcilla, CEE, MOE, in grateful acknowledgement and profound appreciation of sharing his time and expertise as technical resource speaker for the 2021 third IIEE CDO technical webinar and first general membership meeting with the topic, a global and holistic perspective for energy management, conducted via Zoom on June 19, 2021, 1 p.m. to 5 p.m. Given this 19th day of June 2021 in Cagayan de Oro City. Signed, Engineer Robert P. Ga Jr., Secretary, Engineer Christopher S. Dolino, VP Technical Affairs, and President, Engineer Ferdinand A. Bernasor. So once again, sir, thank you very much for that very enriching presentation. Okay, so let us show our appreciation to Engineer Rojin by virtue of a virtual applause, no, in the chat or thumbs up. So once again, sir, thank you very much.
Thank you. Thank you for the
And
opportunity.
yes, sir. Okay.